Hi, this is Will, and today we're going to take a little video of this automated warehouse. And the automated warehouse is just a regular, this is from the regular scenes from Factory IO. What this is it's a structure that stores pallets in each of these little pads, I guess. And the first pad is right here, right behind the control panel, then the second, third, fourth, fifth, sixth. It goes up to 9 per row, and then over here in the second column, I guess second row up, is number 10. And it's a fairly nice, challenging little project. Now, we start off when we get into the scenes in the edit mode, and you can see that you have these pallets for if you wanted to change things around. You can put in different parts of conveyors and whatnot. We're not going to do that. We're just going to go with what we have. So we're going to put in the run mode. Now you can see as soon as that appears, we see a box. And the reason we see that is Factory IO, it always forces the emitter and the remover on. And you can see the remover's on because it's kind of lit up red arrow, and we can show that here. But if we dock all the tags, you can see that the emitter is forced on and the remover is forced on. So if I release it, we're looking at the remover here. If I release it by clicking on what these glasses are, but for the remover, you'll see this turn off. And see how that turns off. And we can do the same thing with the emitter. So normally I like to do the programs where I control all the signals, so we don't really need that. Now I'm just going to quickly say here, this is where we can pause the simulation so we can stop it at certain points and look at how the signals are behaving. We can reset it, so if I reset it, the box will disappear, or the pallet will disappear. And this last thing is where we can slow down the speed of the system. So this would be normal speed here, then we can go at half speed, and then we can go at 10th speed, 1/10 of the speed. And that's just so you can get better control as it's approaching sensors. And you know, the thing that I think is really valuable about Factory IO, well, the two things are, you get a 30-day free trial. If you want to try it out, it's great. You can also step through the program and you can see what signals you need to control, and then you can write the program. So you can pretty much, and we'll kind of show this, is you can lay out the timing diagram for what the signals happen and what actuators they influence, and then you write the program. So to do this, the first thing we're going to do, well, let me show you one thing first. So right here, this add entry, and the add entry is here. Now all these orange circles with the circle inside the circle, those are our sensors. And the fact that it's lit up where some of these aren't means that the signal is high, and that's also by the gold here. And if you hover on it, it'll say it's a sensor. Now if I hover on the entry conveyor, it tells you it's an actuator. And this one is high, so it's receiving a signal. It's because it's a retro reflector. And so the sensor is sending out a signal which bounces off this optical mirror and then comes back to the sensor. That's why it's turned on. Now the conveyors are turned off, so that's why they're white. Now if I put an emitter in here by forcing it on, and forcing it on is when we click on the little actuator symbol that's associated with the emitter, so I'll just click on that. You can see that the add entry went from gold to white. That's because the sensor is now blocked. So the first thing we can do, well, we can release this because we don't want boxes coming after each other, you know, one after another. But we can see that the actuator is the entry conveyor, and then we see a load conveyor. And those are the first two that we're going to do. So to try to get it right, I'm also going to slow down the speed to half speed. And what I want to do is move the pallet down to about this point here. So we've got the entry conveyor, which are these full-length rollers, and then we have the load conveyor, which are these little pint-sized rollers on either side of the conveyor. So I want to stop it right about here. Then I'm going to turn on the load conveyor, and let's try to get that. And when I stop it, I'm going to stop it with the pause. So I'm just going to click on this pause the simulation. And so I'm going to force on the entry conveyor. Okay, and stopped it a little late, but that's okay. So now what I'm going to do is I'm going to turn on the load conveyor, and I'm going to keep it on until I see this at load. Now the at load is, this is the sensor, this is the retroreflector, and I'm going to turn on the load conveyor until I see this go from gold to white, and then I'm going to pause it again. So here's my load conveyor. Now I'm going to unpause it. When I see this go white, I'm going to repause it. Okay, so now what we have, and let me try to click on a little different view of this. This device right here is kind of like a forklift without the fork truck. And you can see it's got forks right and forks left. It also has an at right, and you can't see it, but there's an at left signal down here. And then there's also an at middle. So right now it's sitting in the middle. And anytime we want to move the pallet to the shelving over here, it has to be at the middle position. Otherwise we're going to hit the structure either here or here. So, and we can release the conveyors, we don't need them anymore. And just to show you, the first thing we need to do is we need to go forks left. And watch where the forks go underneath the pallet. And I'll unpause it. And you can see they go right underneath the pallet. And now the at left signal goes high. Now what we can do is we can lift it up, because we need to, and let me show this a little better, we need to lift it off the conveyor. So if we hit the lift signal, you can see that it lifted off the conveyor. Now that we have it lifted up, we can take the forks left signal off, and we can wait until we get to the at middle signal. So what we want to do is we're going to release this, and we're going to wait until we get the at middle signal go high. So we release it, at middle signal right here, so it's at the middle. So now we can move it into position. Now this part is important. Down here is something called target position, and that means where do you want to move it to. Now we said what we're going to do is we're going to move it to this first position. So I'm going to change that to a 1. And you can see it's forced on. Now, as soon as I click anywhere outside of the box here, it's going to move to the position right here. So, okay, you can see that. Now, what I need to do is I need to move the forks to the right position, which is towards the structure. Okay, so now it's in position. So now and you can see it's at right. And you have to make sure that it gets all the way, if you're going left, you have to see the at left. If you're going to the middle, it's got to be at middle. But now what I can do, because it is at right, I can release the lift signal, and it's going to set it down on the structure. Okay. And now that it's set it down on the structure, I can also release the forks right signal. And again, I'm looking for it to go back to at middle. So when it gets back to at middle, Okay, now here's the other important thing. So, what we're going to do is we're going to increment all these positions. We want to fill 1, then 2, then 3. But when you want to go back home, you've got to fill this with spot 100. Okay, and again, when I click anywhere outside here, it's going to go back to that position. Okay, now the other thing you need to know is there's these two signals, moving X and moving Z. And the way we're going to set it up is, well, first, if I do lift, you'll see them, well, at least the moving Z, because it'll just be going straight up. But that'll turn on, and you can see it right here. You can see it turns on for a little bit, and then it'll turn off. And if I release it, it'll do the same. And if I go to a position, and I'll just, I don't know, I'll pick one that I know and makes it go for quite some time. And now you see both X and Z go high until it gets into the position. So they're both high, and it's moving into position. And so Z went off, and now X went off. And I'm going to go back home. So to go back home is, again, it's always 100. That is not going to change. And you'll see these go high, and then when it gets back home, they'll again go low. Okay, they're high, and then they went low. Now, that's going to be how we're going to approach this project. And I'm going to pause it here and then turn on our timing diagram. And you can see the steps that I have put in here, and then you can put in there and, program your PLC. Doesn't have to be this way, and I'm not saying mine is the best way, but this is an approach you can use. Okay, so this is the way our signals are going to work here, or at least in my little version of it. We start off, we're going to send out an emitter signal, and when we get that emitter signal, we're going to get the at-entry sensor. The at-entry sensor is going to turn on the load conveyor. Now, this is a signal that I was playing around with originally, but we're not going to use anymore. And what we have is we're then going to turn on the load conveyor, and when it gets to the at load signal, which is a signal like right at the lift point, we're going to turn off both conveyors. So when we get to the at load point, what we're going to do is we're going to take our forks, we're going to make them go left. When they get to the at left signal, then we're going to lift. And we're going to lift it up. Now remember, when we finish moving, and this says move Z, but it's really move Z or move X. When it stops moving, what we're going to do is we're going to have a counter that counts, and I call it mode here, but every time it stops moving, we're going to have it count. So the first time it moves, we're just lifting it up, okay? And then what we're going to do when it gets to the at middle is we're going to load it with the position we need to go to. So the first position is going to be position 1. Now, as soon as we put a different position in there, it's going to start moving by itself to that position. Okay, so it moves to the first place where it can store. When that gets finished, we're going to move in a 2. And the first thing we're going to increment the counter, and it'll go to 2. Now the first thing we're going to do is we're going to, set it in position. So we've got to move the forks right. When the forks are right, what we do is we're going to set it down on the rack. So when we get to the at right point, what we're going to do is we're going to get rid of that lift point or pulse. So we start the lift when we first have the forks underneath it all the way over to here, and then when we get to the forks are at right is when we turn off the lift signal. And again, when we'll send the lift down will happen automatically, and when the lift goes all the way down, again, what we're waiting for, because we'll get rid of the at right signal, or we'll turn off the forks right signal. So again, it'll move towards the middle. When it gets at the middle, that's when we're going to load in the position that says go home, which is position 100. So this position will just be incremented every time we load it in a different slot. Then over here, when we're going home, it's always 100. So I'm just, because it's already kind of a long video, I'm going to just make most of the logic in Control IO, and I figure people who are looking at this video have probably used the Control IO and know how to use it. I will show some of the very last logic, because there is a couple things that I kind of found unusual, and we can take a look at that, and then we can take a look at the full logic and we can explain that. Okay, so now this is the logic that we have, and right here is start-stop logic. And what we mainly use are these RS flip-flops, and they're set reset. And set turns the output high, reset turns the output low. And you can think of it as on-off. Now, there is this RS, there's also this SR, and let me see if I can put them in here. So this is an RS, and this is the SR, and they look very similar. Now, if you zoom in on these guys, the only difference is the reset set flip-flop, the RS, you can see it says reset 1, and the set reset flip-flop, you can see that it says set 1. Now, what that means is if both of these are 1 at the same time, the reset is the dominant one here, and the set is the dominant one here. So if these are both 1 at the same time, this will be a 0 because you've reset it. If these are both 1 at the same time, the output is going to be 1. It's going to be high. Typically, you don't want that. And you want to make sure that you're not using this one. You want to make sure that you're using the one that has the reset dominant. Now, when you do the logic correctly, they should never be the same. They should never be high at the same time. So having said that, let's take a look at our logic. The start, when we hit the start push button, this output is going to go high. And I always have a signal that I call start process. And it's also going to turn on the start light. And it's because this is not, it's going to turn off the stop light. And you can see here, and what I like doing for the Control IO is I like putting the Control IO right kind of in the middle of the actual factory IO. So let me just minimize this for a second. So these are the sensors for the factory IO, and you can see the ones that are high are lit up, the ones that are off are not lit up. These are the outputs, or the actuators. I like putting my factory IO in between those two, so I can look at those and come on. So I can see, like for instance, stop is high. Now you can see stop is high here because this is also lit up. Now we haven't hit start yet, so that's not lit up. The emergency stop, which I put in here, is also high. And you can see that here. The emergency stop is high, the stop is high. So that's just the start logic, and then I use the start process to say when that happens and the start bit occurs, you know, we're going to get our first emitter. And then I also have this as emitter bit. And we're going to set it with either when we press the start and the start process is high, or we have this signal next box. So we're going to automatically keep the machine moving, and we're going to do it with this next box signal. Now the signal that turns this off is this reset signal, and that's when it gets to, you know, we have it at the add entry. Now because the add entry is normally high, we have to, you know, knot it to get the low signal. So when it goes low, this will go high, and that will turn off the emitter signal. And we have the entry conveyor, which that also turns on the entry conveyor, and what turns it off is when it's at the at load. And we have the load conveyor, which we're going to turn on again when we're at add entry, and we have an emitter, and then we're going to turn it off again when we get to the at load. Now when we get to the at load, we're also going to start the forks going left, and we're going to use that. This is the falling trigger, and that means when the signal, as soon as it falls, we're going to send out a pulse that's 1 scan wide that will be high for 1 scan, and that will trigger this to turn it off, and it'll trigger the forks to turn on. Now again, we're going to reset this with the move complete. So when the move is complete, you know, this signal will turn off the forks left. And again, the first time we move it is the lift signal. So this is really when the first lift signal, you know, we've lifted it up, and now after we've completed that move is when the forks left will be turned off. And here's the lift signal. So when we're at left, we lift it up, and then when we're at right is when we set it down on the structure. And over here, yep. Now here's where we have our counter. Now this is our mode counter. So this is mode. This is counter up. When we get the mode complete is when we count. When we get our next box is when we reset it, and we've just set the preset to 4. Now here is where we just have our load position, and this is the position in the rack, in the structure, that we are going to keep incrementing every time we fill up. You know, we fill up position 1, then we fill up position 2, we fill up position 3, and so on. And this is just a counter that we're going to count the positions, and I've just put the terminal count at 54, and I think that's about right. And so this is the load position that we're going to aim for. Now this is part of the logic that I got a little problem with, but so when we're in mode 1 or mode 2, and these are just equals, let me try to zoom in a little bit. So these are equals. So when mode is 1 or mode is 2, and this is an OR gate, what we're going to do, and first we have this assigned. You know, the one odd thing with this Control IO is you don't have a way to move like you normally would. I wanted to move like a number 6 into a certain spot, because over here is what we're going to have the source position. So the source position, you know, when we're at home is position 0, and when we're moving to the load position where we want to load it, we have to put that into our source position, or what I call source position. Now, the way you move it is there's this assign bit, and let me show you what this has. If you go in the documentation for Factory IO, they have pretty good documentation for the Control IO. And this assign, which actually appears in the extra function, what happens is if this signal on the input is high, you'll be looking at what is coming into PT2. If it's off, you'll be looking at what's coming in PT1. Okay? So the way I have it set up is that when the counter is 0 or 1, which means you're moving to the position or you're at the position, that'll be a logic high, which means you're going to be selecting this load position. Otherwise, presumably you'll be at home or going to home. Well, you'll be at home, so you want to put in a 0. And so this is the logic that accomplishes that. Now, the thing that's, and I'm not quite sure, I know the intricacies, I think because when you switch from this to this, there's a delay. So what I had to do is when the signal goes high, to give it enough time to switch to the load position, I had to put a timer in there to effectively put a delay in there. Now this would be a delay of 2 seconds. So it just gives it a little delay so there's enough time for the load position to get into this source position, if that makes any sense. Now, what we're going to do now is we're going to put in the same type of circuit. So what I can do is I can sort of copy this whole thing, and hopefully we can, and you can use Control C, Control V, and we're going to paste it down here. Now everything's still highlighted so I can move it. Now here, what we're going to do is, instead of this, well, we can get rid of this guy. Because now what we're going to do is we're only going to be interested in when we're at mode 3. And mode 3 again is we are trying to get back home. So we don't really have an OR gate here. What we're going to do is we're going to have, what we really need is we need an AND gate. So we're going to delete that. We're going to put in a 2 in AND, drag it in here. And I don't think we need this timer in here either. And the other signal that we're going to have, so we're going to have when we're at mode 3. Now the other signal that we need, and if we go into our tags, we need the at middle signal. So again, when we're in mode 3, we have to wait until we're at the middle signal, and then we can put this into the assignment. Now here, what we're going to have is, instead of this being position 0, we're going to delete that, is we're going to make that the source position. And we're going to move that down here, and we can just wire that there. And now this, instead of this being the load position, we can delete that, and we can copy this, put this down here, and we can make this, because here we're going home, so this is always going to be position 100. So let me 100. And now instead of this being the source position, what we're going to have is this is going to be our target position. Oop. And you don't want to click on this one over here. I made that mistake. What you want to do is you want to make sure you're picking everything from the Control IO signals. So we want the target position from here. So what we have is we have a choice. You know, this is the final thing that's going to determine the move. So when we're in mode 1 and 2, the source position is just incrementing from spot to spot to spot. When we're in mode 3, then we're going to go to 100. So only in mode 3 is this signal going to be true. So it's, you know, if it's not in mode 3, it's going to be looking at the source position. If it is in mode 3, it's going to be looking for going home, which again is position 100. Now, what we don't have on here is we've got to put in the logics for moving our forks to the right position. So again, and you know, the easiest thing is if you have the logic and if you can fully copy it, yeah, come on. Okay, Control C, Control V. So here we're going to do, and you know, again, for forks right, the when forks right goes high, we're still at mode 1. It's the very end of mode 1. And we need 2 in and you know, to work these, there's actually 2 sliders. There's one to move up and down for the tags, and then there's one to move up and down for the full thing. So we're going to put in 2 in and we'll connect that up. And the other signal we want here is we want our move complete signal. So, you know, all these purple things here are just memories that we've picked. So if we go back up here to memories, and these here are integers, and what we really need is we need the bool. So now this is picking the next unused bool, but what we really want, and if you click in here, it'll give you the addresses. What we want for this one is we want the move complete signal. So that's the one that we want. So when the move is complete, and the 2 in and, we're going to go into the reset set flip-flop, and this will be controlling the forks right signal. So the forks right is an out, it's an input over here. So forks right, we can drag it in over here. And again, what reset set signal is when we get to mode 2. So what we can do is we can pretty much, well, and we even need an AND gate too. So we can copy all this with Control C and Control V and try to move it into the spot. Now, so the output here is going to reset it, and let me try to zoom in a little bit so I can make the connections easier. And this one, we're going to, when this gets to a 2, is when we're going to reset it. And again, we're going to use the move complete signal as, you know, the signal that resets it. So when we lift it down is when we go from step or mode 2 to mode 3. So when it's at mode 2, the very end of mode 2 is when we're going to set this down in place. And then our final thing that we need to do, we've got it right now, we just have to put in the signal for the next box. And again, grab them all. So, you know, we're using the mode counter to say what mode we're in, and then we're just using, you know, these comparisons, and we're going to do the next box when we actually count from 3 to 4, which really wasn't on the timing diagram, but all we're going to do with when we count to 4, which we actually do count to 4 when we move home. We're moving home on count 3. When it gets to the home position, it goes to count 4. Now again, what I had to do to kind of make it work was go in here and put in a timer that gave it a little delay here. And so when we temporarily get that count 4, and I had that set up for a short period of time, so when you're putting these in, these are the modes, so they're just integers. When you're looking at the timers, these are in milliseconds. So right now this is 800 milliseconds. The other timer that was in there was like 2000, which is 2 seconds. So this will count out, and it'll put in a delay of, you know, 800 milliseconds. And what we're going to do is we're just going to create a bool memory, and we're going to put that on the Q output. So when it times out, this signal goes high. Now this signal, and again, if you click on the box, it's going to say, what do you want to name that? And we're going to name that next box. And so what does the next box do? It does two things. First off, the next box is where we have our counter. Not that counter, that's the position counter. This is the mode counter. So we have the mode counter. We put the next box into the reset. So as soon as that signal goes high, this will go back to 0. So it counts up 1, 2, 3, a quick 4, and then right back to 0. And then the other place that we have next box is right here, which is the next box, which is the second and every subsequent emitter. So the first emitter is when we press the start push button. All the other ones are virtue of the next box. So that is our program for Control IO. And let's see, we can minimize that. And the Control IO, if you go into the drivers, well, let me show you here. If you go into File, you go into Drivers to set up the Control IO. You know, you can set it up for all these different Allen Bradley stuff. There's some Modbus, and then there's Siemens. But here's the Control IO. So if we go back here, we want to make sure that all our forces are released when we start this. And again, you can see when we're in this spot right here, that's the target position of 0. So let's take a look. And I'm going to speed it up to normal speed. The forks go left, they lift it up, go to position 1, and you can see target position is position 1. Okay, let's go ahead and set it down. And you can see every time it moves, you're going to see sometimes when it's just lifting, ooh, my next box isn't working. Okay, I'm going to pause it for a second and see what's going. Okay, well, I have the next box and I put it as bit 4 here, and I'm going to have to pause this. But up here, let's see. I actually have the next box as 3. So, and let's see what it is at this counter. This next box is also 3. So I've got that wrong. So we'll make that 3. Now, sometimes just to make sure everything is good, we'll have to reset everything. Reset here. And take it off pause. Now, when we take it off pause, it goes off pause here too. So let's see if that was our mistake. And this should be pretty quick to confirm. So again, this going into spot 1. Now you can see when we go back to our position, it goes to 100. Here's the second box. So I think that was our little mistake, my fault. Happens a lot when you're doing this kind of live. Should pay better attention to this stuff. But, you know, you can see it'll just keep going back and forth. Position 100 to go back home. I'm going to get another emitter box. And then you'll see this go to spot 3, which it should. That's 3. You load it in place. And again, you know, the stuff is, you know, you can walk through what position and what you need to control, and then you write the logic to do it. And, you know, Control IO is all this, what they call function block diagrams. It's not ladder logic. But if you wanted to write this in ladder logic, then you're going to need some PLC software to do that in ladder logic. But this is a good way to learn how to do it. A function block diagram is used, you know, not as much as ladder logic. Ladder logic is used primarily because it's all visual and you can see what's turned on and what's turned off. But function block diagram is probably the second most used type of logic that there is. There are other types, but for the other types you certainly are going to need the PLC software to be able to use it. And so I think what we're going to do here is we're just going to wait until it fills up the first row, and then we'll just see it go into the second row. And again, it's going to be the same thing because we're just incrementing each spot. So let's see, we're at 1, 2, 3, 4, 5, 6. Is that true? 1, 2, 3, 4, 5, 6, 7. Okay, 7, 8, 9, and then that'll be 10. Once we start on the second row, I think we'll kind of leave it at that because this is a long video right now. I can't imagine how long it would have been if I would have shown all the software, or I mean, making all the connections for the Control IO. But you know, you can take a look at it. You know, see if you can put together all the logic that you need. See if, you know, I'm still not convinced that I needed all those time delays in there, but you know, it seemed like that was the only way I could get it to work. Maybe you can do better and get it to work without those delays. So give it a shot and see what it looks like. And you don't really have to load it in order. You know, for instance, there could be something that says, you know, maybe you want, you know, like maybe you want all these heavy boxes on the first row, and then maybe, because, you know, you get the packages, you know, right now it's 8:1 ratio, so maybe you say, well, I'll load these steel things down in the first row, and then you know, the regular boxes starting up in, like, I don't know, row 3, 4, 5, and 6. But then you'll need extra logic to control, you know, what position you're loading into. And you'd also need some type of sensor to say, oh, this is a metal box. And they do have, you know, what you'd use. Well, now we're getting all metal boxes, so maybe I'm wrong. But they do have inductive sensors where you can just look for metal objects. Now, at some point, you'd have to put a sensor where before you started lifting it up, you could identify it to be metal or not metal. But, you know, you might want to give it a try. So anyway, now it's all metal boxes. Anyway, you know, take a look at it. It is kind of challenging. It's a good test of your program abilities. Good luck. Thank you.